Very good morning to one and all present here. Now we are in class number 3, projection of points. First, let us understand the basic the problem definition. What do you mean by a point? A point is a dimensionless entity which does not have any width, height, and depth. The location of the point is represented by a line joining two intersections. So that will help you to locate where is the top view and front view in a pictorial representation as per the first angle projection. So here for your example, see the point is located by the intersection of lines. So we can able to see the distance of the front view as well as the plan, the top view of the point with reference to the horizontal and vertical plane. Now let us go with the positioning of point in various type of quadrant as listed here. So you take the first quadrant. So the point lies in the first quadrant, which is situated above the horizontal plane and in front of the vertical plane. If any problem given related to the first quadrant, so you have to refer the boundary conditions above horizontal plane and in front of the vertical plane. The next second quadrant, the point is positioned in the second quadrant. So it will be above HP and behind vertical plane. And similarly, third quadrant, when the point lies in the third quadrant, it will be located below HP and behind vertical plane. The last one, the fourth quadrant. So the point situated below HP and in front of the vertical plane. So later on, we are going to solve problems on each type of the quadrant system in order to understand the different view of a given object. Now, what are the various system of notations to describe the point as an object? So here, the point from the problem statement can be referred as A, B, and C respectively. The front view can be represented with a lowercase letter with a dash, say for example A dash, B dash, and C dash. Then the top view by the lowercase letter, simply say A, B, and C, etc. And the visual ray line, that is the projector line, so which will be marked by using a 2H pencil by mentioning a thin line to view the different object with reference to the front view and top view angle. This is just a system of rules to be followed for naming the front view and top view with a different symbol, the notation. Now we will go to the simple problem. Consider a point which is positioned in the first quadrant. It is named as A. The point which is named as A, capital letter A. So the distance from above the horizontal plane, 20 mm. The point A is located at a height above the horizontal plane, 20 mm, and 30 mm in front of the vertical plane. So in this problem, we need to draw the front view and top view with reference to the first quadrant. So now referring to the pictorial projection, the 3D projection. So consider vertical plane and horizontal plane. And this is the observer viewpoint. Okay, and the final object, say point A, is positioned in space between vertical plane and horizontal plane. with the coordinate, the distance that are given here, 20 mm above horizontal plane and 30 mm in front of the vertical plane. Okay, so the observer viewing from the front view direction, so the point A is elevated at a height of 20 mm above the horizontal plane, and the point A is projected towards the vertical plane. So it will be measured as A dash. So here in 2D orthographic view, draw XY line. So place center point O. From O, draw a projection line, a thin line, 20 mm height, and place the point A dash. This is the front view distance. Then the top view. Now the observer viewing the point A from the top view angle. So it is situated 30 mm in front of the vertical plane. The point A is made to projected on the horizontal plane. Okay, and this horizontal plane is tilted at an angle 90 degree clockwise, so that the top view located here below the XY line. You can see the 2D, the projection, orthographic projection. So the top view is located at a distance 30 mm in front of the vertical plane, and it is named as A. So in this problem, what is asked? So we have to draw the front view and top view by referring to the distances. Then next we will see the projection of point in the first quadrant with a little bit change in the dimensional parameter. So in this problem, draw the projection of a point A which is lying on the horizontal plane. The point A height is not given. The A is lying, the point A is lying on the horizontal plane, and it is situated 30 mm in front of the vertical plane. So draw the projection. Okay, so this is the front view and top view direction. So the observer viewing the point A from front view. So, so project the point A on the XY line, on the mid of XY line. So mark it as A dash. You see here in 2D projection, orthographic view. So it lies on the middle of XY reference line. So the front view is named as A dash. Okay. Then the top view distance given here 30 mm in front of the vertical plane. Already the point A exactly lying on the horizontal plane. So now we have to turn the horizontal plane by rotating 90 degree clockwise, so that the top view will be drawn below the XY line. See, in orthographic view, the 2D representation, see the point A is drawn at a distance of 30 mm from A dash. So connect A and A dash by drawing a projection line. In the previous problem, they have given the front view height 20 mm above horizontal plane, but here the front view lies on the reference line. There is no height given, only the top view distance in front of the vertical plane that is mentioned in the question. Now we will see the second quadrant. Consider a point which is positioned in the second quadrant, say 25 mm above the horizontal plane, the point B, and 35 mm behind the vertical plane. So draw the front and top view by mentioning the projection lines. So this is the second quadrant. So we have to draw an orthographic projection, construct a XY line. So in second quadrant, there is one difficulty. When we are turning the horizontal plane 90 degree clockwise in this direction, both vertical plane and horizontal plane will collide with each other, overlap with each other, so that both front and top view will be lying in the same line of projection. It is not like first quadrant. In first quadrant, the top view will be located in separate plane and front view will be positioned in a separate plane. Whereas in second and fourth quadrant, it is not like that. Both HP and VP will be overlapping, colliding with each other. So in 2D, if you draw in 2D, see the vertical plane and HP plane will meet in the same direction. So mark point O the mid of XY. So mark B dash at a height of 25 mm. So as given in the problem, the point B is situated at a height of 25 mm above the horizontal plane. Now project point B with reference to front view. So B is projected on the vertical plane. So mark it as B dash. So this is named as B dash. Now the point B is located 35 mm in front of the, behind the vertical plane. Okay, referring to the previous pictorial representation, 35 mm, the point B is located 35 mm in front of the, behind the vertical plane. Okay, so view the point B from the top view. So the point B is made to project on the horizontal plane. The top view will be lying on the horizontal plane and front view is positioned on the vertical plane. Now rotate the horizontal plane 90-degree clockwise. So B will be projected here above B dash at a distance 10 mm. The total distance is 35. So by taking difference 35 minus 25 here at a span interval distance of 10 mm. So mark B. Okay, so join O, B dash and B by drawing a single projection line. So both front and top view are meeting in the same line of projection. So this is one of the disadvantage why the second quadrant is not followed in most of the civil mechanical drawings in Indian manufacturing companies. So only first angle projection is most widely used for representing all civil and mechanical diagrams. Next, projection of point in the third quadrant. So this is the third quadrant. So what is the condition given? Consider a point C which is located 35 mm below horizontal plane and 25 mm in front of the, behind the vertical plane. So draw the projection by mentioning the top view and front view. Okay, the observer seeing point C from the front view direction. So the 35 mm below HP. So the point C is projected on the vertical plane. Okay, so that will be named as C dash. The front view will be lying on the vertical plane in the third quadrant, whereas the top view will be projected on the horizontal plane. Okay, so now the top view is located at a distance of 25 mm behind vertical plane. So the point C lying on the horizontal plane. So rotate horizontal plane 90-degree clockwise. Okay, so mark point C on the horizontal plane. So obtain the top view on the horizontal plane itself by mentioning 25 mm behind VP. So this is the final solution in orthographic projection. What is the difference between the third angle projection and first angle projection? In first angle projection, the front view will be drawn on the vertical plane, okay, whereas the top view will be drawn on the horizontal plane. Here, the front view is positioned on exactly below the XY line, and top view is located above the XY line. Another simpler differences we can able to tell here. So in first angle projection, front view above XY line, top view below XY line. But here, please make a remembrance. In third angle projection, front view is located below XY line, top view is located above XY line, reference line. So this is the slight interchangeability between the first angle and third quadrant. So the last one is the fourth quadrant. Consider a point D which is situated 30 mm below horizontal plane and 40 mm in front of the vertical plane. Draw the projections. So like second quadrant, you have to follow same thing for the fourth quadrant. But what is the change in the conditions that has been mentioned in the question? Instead of behind, in front of vertical plane, 40 mm in front of the vertical plane. So draw XY line. Okay. So the observer viewing the point D from the front view direction. So 30 mm below horizontal plane. Okay, the point D is projected on the vertical plane D dash. So draw a projection line for a distance, say 30 mm, and mark D dash from O. Then view the point D from from top view direction. So 40 mm in front of the vertical plane. Okay, so the top view lying on the horizontal plane. Okay, so the point D is projected to lie on horizontal plane. Its mirror image, the reflection, the projections are seen on the horizontal plane, the point D, the top view. Now rotate the horizontal plane 90-degree clockwise so that both horizontal plane and vertical plane will, here also it will collide with each other. So below D dash, okay, the top view will be measured at a distance of 10 mm, okay, by marking a point D. Okay, from O, the total distance is 40. Okay, so this is the solution for the fourth quadrant, which has been given in orthographic method. With this information, I thank every one of you for listening to the topic projection of point. In the next class, we will see orthographic views in some other occasion. Until then, thank you very much. We will meet in the next occasion with a different topic.